Hi, in this video I just want to show you one of my books. So this is a book I've had for a really long time, I guess about 15 years now. It's called Abstract Algebra, a First Course, and it was written by Dan Saracino. And you can see my copy here is pretty worn, and this is my fault just from moving it around on the bookshelves and throwing it in boxes and rearranging things. This is what happens to books after a while. I really wish my copy was in better condition, and it's entirely my fault. So I thought I would just make this video just to talk about this book and tell you whether or not you should buy it, if you shouldn't buy it, who's it for, the pros and cons. I'll leave a link in the description to this video, to this book. So in my opinion, this is probably like the easiest abstract algebra book that you can buy. It is definitely for beginners. It is not a perfect book for various reasons, and we'll talk about why. And it's also a very good book for various reasons, and we'll talk about why. So let's just go ahead and open it up. I'm going to show you the inside. Abstract Algebra, Dan Saracino, Colgate University, Waveland Press, Inc. I actually, long ago, I taught a course with this book. It was kind of like a little independent study with just a couple students, and we went through a decent amount of the book, and these were students that they didn't really have like a proofwriting background, so I had to teach them how to write proofs, and some of them were really awesome. So here's the contents. So you can see it starts with sets and induction, binary operations, groups, fundamental theorem about groups, powers of an element, cyclic groups, subgroups, direct products, functions, symmetric groups, equivalence relations and cosets, counting the elements of a finite group, so it's like Lagrange's theorem, normal subgroups, homomorphisms in normal subgroups, direct products and finite abelian groups, the CELO theorems, rings, subrings, ideals, and quotient rings, ring homomorphisms, polynomials, and then from polynomials to fields, and then UFDs, which are unique factorization domains. Answers to selected exercises, so it does have some answers to some of the problems, but I would say it's not significant. You're really not going to get that much in terms of answers. So it starts off with sets and induction, and it has like this introductory section on induction, which you could read and you could learn from if you didn't know about sets and induction. I have pretty much read, I think, this entire book. I've actually read the entire thing, and I've done a lot of the problems. Apparently I didn't do these though. Usually I would circle them or scratch them out, but I kind of feel like I have done these, so maybe I just didn't want to write in the book, because I've worked through pretty much the entire book. Section 1's on binary operations, so I know I've done a bunch of the problems here, and again, I just, for some reason, I didn't write in the book, which I probably wouldn't today. I've got a pencil here, and I'm not going to write in this book. So, yeah. So the pros of this book are that it's very easy to read. It's very well written, and it has exercises that are appropriate for the level of reading. Also, a lot of the problems are very standard, so you'll find them in other books. And if you're taking a class in college, by having this book, even if you already have a book, you'll gain access to extra exercises which might end up being test questions. For example, here's some very popular problems. Look at number 11. Let G be a group such that x squared equals e for all x in G. Show that G is abelian. So if you think about that statement, if you know any group theory, basically saying x times x equals e, that means that every element in this group is its own inverse, which is pretty cool. And when that happens, the group is abelian. So yeah, this one's a little bit harder. 14's a little bit harder. And so is 15. 15's a little bit harder as well. Yeah, pretty cool. And then 4 goes on to cyclic groups. Does pretty good here. One of the things that is lacking in this book is content. So for example, if you want to learn like field theory or Galois theory, let's go to the back of the book. I mean, it does do some stuff, right? It talks about polynomials, but this is section 20. And so now it talks about UFDs. I actually read these sections via self-study when I was a graduate student, because when I was an undergrad, we didn't cover all of these sections. It talks about PIDs, okay? And it eventually ends. I think this might be the last section. Let's see. That's it, right? Suggestions for further reading. So that's it. So the book ends. And that's honestly one of the worst things about the book. Another con is sometimes the proofs in the book, I mean, they are well written, but the best proofs are the ones you write. So for example, here's a proof where they show every integral domain is a field. I actually have a YouTube video of this proof that I wrote. So it always makes more sense when you write it. So good book. I think it's worth buying if you are trying to learn abstract algebra. If you're a book collector, yeah, definitely worth picking up if you can find a copy at a reasonable price. I don't think this book is super inexpensive anymore. When I bought my copy several years ago, I paid like not so well. I think I bought it new, and then I think copies after that, used copies were about $10 a piece or so, or maybe less. But I think the price has gone up since then, you know, inflation and all that stuff. But yeah, pretty good book. It's got a nice sections on functions that appears before symmetric groups. So yeah, these are things that you would see maybe in a proofwriting class or in a discrete math class. You would prove a lot of these things. For example, here, number 10, show that f is 1 to 1 if and only if there exists a function g such that g of f equals the identity on S. And then here you have some other things that you would prove perhaps in a proofwriting class. So very nice book. I recommend it. Good for beginners. Oh, look at this. I've circled some stuff here. It's funny because, you know, I've done most of the exercises in this book, but I decided to circle these and I didn't circle the other ones. I also did this one here, show that f and g are disjoint cycles. If there are disjoint cycles, then fg equals gf. Cool. Yeah, this is on the section on symmetric groups, which it's a tough section for people to learn. It takes some time to get used to the proofs in dealing with symmetric groups, and the cycle multiplication is actually easy once you learn how to do it. This book does actually have good examples of cycle multiplication, I believe. Yeah, it's got some here. There's an example there. And I think there's some examples here as well. So not too many examples. Most books don't have too many examples of cycle multiplication. I know I made some videos on that. Also, it does the cycle multiplication right to left in this book. If you go on the internet and you use like Wolfram Alpha to compute your cycle multiplication, it does it left to right. So in my opinion, that's a little weird. Frolay's book also does it that way. So I think this is a little more standard. Anyways, just a random video just to show you one of my books. It's Abstract Algebra, first course by Dan Saracino. I've read pretty much the whole thing. I've done most of the problems. Biggest con, if you're trying to like learn a lot of abstract algebra, you're going to need more than this, right? Biggest pro, it's great for beginners. Good luck.